Projection of points. So how to draw the projections of a point? So we know that a point is a dimensionless character. That means it has no dimensions. So it is represented by a symbol, that a dotted symbol. So you can represent it by the symbol of point should be represented by using this dotted symbol, having the dimension up to 2 mm thickness. So a point is a dimensionless character, it has no dimension. So and it is represented by a symbol, a dot. So coming to the conventions, that means, so how we will draw the projections, that means how we will draw the front view, top view and side view in case of points. So the front view is represented by small letters in case of points, and also in lines, and also in plane surface and solid surface. We can represent it, always the front view will be represented with small letters with the dashes, A dash, B dash, C dash, D dash up to so on, etc. And the top view will be represented by the small letters without dashes, A, B, C, small letters. We can represent it like that. And the side view is represented by the small letters with the double dashes or small letters with the suffix ones. So A double dash, B double dash, C double dash, D double dash like that, or A1, B1, C1, D1, etc. like that. So we can represent the side view like that. And also coming to here, I am drawing a diagram. So this diagram representing about a three-dimensional view. I am drawing the horizontal plane and also the vertical plane. The line of intersection between the horizontal plane and the vertical plane, we can call it as the XY line. So I am placing, this horizontal and vertical plane forms 4 quadrants. This is the first angle projection, second angle projection, third angle projection and fourth angle projection. Suppose whenever an object is in the first angle projection or in first quadrant, the position of the object is very, very important. Suppose if the object is in the first quadrant, the position of the object lies above HP and in front of the VP. If you see that, above HP and in front of the VP. Suppose if the object is in the second quadrant or in second angle projection, the object lies above HP and behind the VP. So this is the position of the object whenever the object is in the second quadrant. Suppose the object is in the third quadrant, the position of the object is below HP and behind the VP. So this one is very, very important one, position. So by using the position, so we can draw the projection. That means we can draw the front view, top view and side views. And coming to, suppose if the object is in the fourth quadrant, the position of the object is below HP and in front of the VP. So these positions are very, very important one. So always the horizontal plane 90 degrees clockwise direction you can rotate it, and we will draw the projections in the orthographic projection. Coming to the thick lines and thin lines in projection of points or in lines or in planes and solids. So coming to the thick lines, that means you can draw by using a 2H pencil. Thin lines are drawn by using a 2H pencil, like projection lines, construction lines, XY line, dimension line. So these lines are drawn by using a 2H pencil. And thick lines. So for drawing the thick lines, you are using HB pencil. For point representation, in case of points, so for point representation we can use the HB pencil. And lettering, like you can mentioning the dimension value, and also you can representing the small letters, front view and top view and side view letters. Also you can represent it by using the HB pencil. So this is about the conventions about the projections of points. And coming to the procedure for drawing the projection of a points. So for drawing the projection of a point, so first of all, after seeing the problem, so first of all we can identify the point where it will be situated in which quadrant. So the point is situated in which quadrant, we can identify first step, and after that draw the rough diagram, or you need not to draw the rough diagram. directly we will draw the actual diagram by drawing the XY line and represent the front view, top view and side view. So the rough diagram is very useful for understanding purpose. So we can draw the rough diagram of that quadrant. Suppose if it is in first quadrant, we will draw a rough diagram of the first quadrant like that. Suppose if the object is in the second quadrant, we will draw the rough diagram in this manner. And if the object is in the third quadrant, we will draw the rough diagram and we will find out front view, top view and side view. Okay, like that. So this is the procedure for drawing the projection of a points. And coming to the important note here. So if you follow a rough diagram for drawing the projection of a point, or you can follow, suppose I am giving one of the technique for drawing the projection of a point. Suppose above and behind means always you can draw the above the reference line. So if a word is there above and behind is there, that means above the XY line. Below and in front of means below the XY line we will draw the projection. Similarly, above HP and below HP means below HP condition. In these two conditions we will draw the front view only. In these two conditions you can draw the front view only. And behind the VP and in front of the VP conditions always we will draw the top view only. So this is the important note. By following this note also you can draw the projections of a point, or you can follow the rough diagram and we will draw the actual diagram from the rough diagram also. So first problem is here. They are giving that here. Draw the projections of a point A lying 70 mm above the HP and 45 mm in front of the VP. So first of all we can identify. So the object is here A. The object is lying 70 mm above HP, 45 mm in front of the VP. So we can identify the object is in which quadrant. Above HP and in front of the VP means the object is in first quadrant. So first we will draw the rough diagram of first angle projection like that. We will draw the rough diagram. So this is horizontal plane and this is vertical plane. I am drawing the rough diagram only in two-dimensional way. So point A is 70 mm above HP. Above HP means point A is 70 mm above HP and 45 mm in front of the VP. So this is the rough diagram. So this is 70 mm. They are giving that. They are giving that 45 mm. So 70 mm above HP and 45 mm in front of the VP. So this is the direction of the front view is like that, and the direction of the front view is like that. Whenever you can see the object from the front, from the direction of the front, so we will get the front view on the vertical plane, and the front view of that point A is notated with small letters with a dash. And whenever you can see the object from the top view direction, we will see on the horizontal plane, we will see the image of the top view, and the top view of point A will be notated with small letter, small a, like that. Whenever you can rotate the horizontal plane 90 degrees clockwise, so we will get the projections. So we will draw this one is the actual diagram I am drawing here. So we will draw the reference line XY. So after drawing the reference line, 70 mm above HP, 70 mm above, we will get the A dash. So this is the reference line. 70 mm above the reference line, we will get the point. 70 mm above HP, 45 mm in front of the VP. So locate the points. So I am locating here point notation like that. So here we will get point A dash, and here we will get point A because it is a top view. So A dash is our front view and the A is our top view. So this is our front view and this is our top view. And also we will draw the side view also. How we will draw the side view for this diagram? So this is your diagram. So like that we will constructing the projections, front view and top view After drawing the front view and top view, we will construct the side view also. So for constructing the side view at the right hand side or at left hand side, just we will draw the another reference line x1 y1. Draw the another reference line x1 y1, and from the intersecting point of x1 and xy and x1 y1, we will draw the meter line. Draw the meter line with an angle of 45 degrees. Draw the meter line with an angle of 45. Now from top view, that means from point small a, we will draw the horizontal projection line and we will get the intersecting point here. From this intersecting point, we will draw a vertical projection line. Similarly, from point A dash also we will draw the horizontal projection line and we will get the side view. We will get the intersecting point. Take this one is the side view, A double dash. We can notating with like that. A double dash, which side view this one? So at the right side of the front view, we will get the left side view. So we'll draw the right side view also. For drawing the right side view, at the left side of the front view, I will draw the another reference line x1 y1. From the intersecting point of xy and x1 y1, draw the meter line with an angle of 45 degrees. Draw the meter line with an angle of 45 degrees. And from the top view, draw the horizontal projection line. We will get the intersecting point. From that intersecting point, we will draw a vertical line. And from the front view, we will draw the horizontal projection line. And we will get the intersecting point. Take this one is the side view. This is our right side view, notating with A double dash. So here A dash is our top front view and A is our top view, and A double dash at the right side of the front view will get the A double dash, that is left side view, and this is our right side view. So like that we will draw the projections of a point whenever a point A is in the first quadrant. So always in the problem they are giving the point notation in capital letter, but we will draw the projections on the reference line, we will draw the projections are with small letters. Suppose if it is a front view, we will give the lettering is give with a small letter with a dash, and the top view, suppose if it is a top view, we will give the dimension as the small, notating with small letter with without dashes, without dash, and suppose if it is a side view, notating with a small letter with the double dashes. So after that we will give the dimensioning. So this one is 45 degrees angle, because it is a meter line. So in the direction of the top view, we will draw the meter line. So here this is also meter line. Okay. So after that I am mentioning the dimensions. So what are the required dimensions they are giving in our problem? That values we can representing here. So from the outline, from the outline, we will draw the 10 mm distance or 8 to 10 mm distance, and we will draw the dimension line and we will rotate the dimension value. So this dimension is, they are clearly giving that 70 and this is 45 mm. So like that we will draw the actual diagram. In examination point of view also we will draw this diagram only. So this is rough diagram is only for understanding. So coming to the second one, draw the projections of a point C lying 50 mm below the HP and 40 mm behind the VP. So we can observe the whether point C is here object. The object is in which quadrant? Below HP and behind the VP we will observe in third quadrant. So the object C is in the third quadrant. So I am drawing the rough diagram. So one or two problems I am representing in rough diagram. After that I am directly following. Draw the rough diagram of the third angle projection. So in third angle projection, this one is, we can call it as the horizontal plane and this is the vertical plane. So they are giving that point C is 50 mm below HP. 50 mm below. So this is point B C. So this is 50, they are giving that, and this dimension is also they are giving that 40 mm behind the VP. So this is the direction of the front view and this is the direction of the top view. So whenever you can see the object from the front view, so the front view is will obtain on the vertical plane. It is denoted with small letters with a dash C dash, and top view is obtained on the horizontal plane denoted with small c. Whenever you can rotate the horizontal plane 90 degrees clockwise, so we'll get the actual diagram is, so we'll draw the actual diagram. Draw the reference line xy. So above the reference line in the third quadrant, whenever you will rotate the horizontal plane 90 degrees clockwise, above the reference line we will get the top view and below the reference line we will get the front view. So take 50 mm below the HP and 40 mm behind the VP. This dimension is also 40 and this dimension is also 50. 40 mm behind means above the reference line. Take 40. Take 40 mm. Draw the projection line. These are the projection lines. These lines are also drawn by using a 2H pencil. So now we are locating the point notation. So this is point C and this is point C dash. So this is our top view and this is our front view. So in case of third angle projection method, so the top view is obtained above the above the reference line. The front view is obtained below the reference line. Now I will draw the side view also in this. So for drawing the side view, and at the left side and also at the right side we will draw the two reference lines, x1 y1. So here also I am drawing the x1 y1 lines. From the intersecting points of xy and x1 y1 we will draw the meter line. So through the direction of the top view we will draw the meter line. In the direction of the top view, draw the meter line with an angle of 45 degrees. Similarly, here also we will draw the meter line. So after drawing the meter line from the projections of the top view, just we will draw the horizontal projection line. So this horizontal projection line will intersect the meter line at one point. From that point we will draw a vertical line. Similarly in this direction also. Next, from the front view we will draw the horizontal projection line and we will get the intersecting points. And now we will draw the side view of the, so here we will get the C double dash and also here also we will get the C double dash point notation. So what is this one? So in third angle projection, at the right side of the front view will get the right side view. At the left side of the front view will get the left side view. So like that we will draw the side views. So here this one is the meter line we will draw with an angle of 45 degrees and here also we will draw the meter line with an angle of 45 degrees. So like that, whenever an object is in the third quadrant, we will draw the projections like that. After we will give the dimensions. So I am following a unidirectional method and I am giving the dimensions in unidirectional method. 40 mm behind and 50 mm below HP. Like that we will draw the projections. Point A is, so draw the projections of the following points on a common reference line. Keeping the distance between the projectors is 25 mm apart. So they are giving different problems here. So in one reference line, one common reference line, keeping the distance between the projectors 25 mm. So we will draw all the diagrams. So first of all I am drawing a common reference line in this problem. I am drawing a common reference line XY. XY. After drawing the common reference line, so first of all I am solving the first problem. point A is 20 mm above HP and 30 mm in front of the VP. 20 mm above HP and 30 mm in front of the VP. The point A is in first quadrant. We will draw the projections. Above means above the reference line. In front means below the reference line. So in first quadrant, so above the reference line we will get the front view. Draw the front view. So 20 mm above, we can take 20 mm above and 30 mm in front. So this is, so like that we will draw the projections whenever a point is in first quadrant. So this is the first problem. And coming to the second problem is point B is 25 mm above HP and 35 mm in behind the VP. Above HP and behind the VP, so the object is in the second quadrant. So we know that in second quadrant, both the projections, that means the top view and front view is we will get above the reference line. So we will draw the projections by taking the distance between the projectors 25 mm. Take 25 mm distance between the projectors and we will draw the projection of point B. So point B, 25 mm above and 35 mm behind. 25 mm above, 35 mm behind. I'm already telling that, so one above and above means we will draw the front view and behind means we will draw the top views. So above HP, so we will get the point B dash. And 35 mm behind means we will get the top view, rotating with small b. So I am giving the dimensions also one by one. I am giving the dimensions also here. I am representing for the first problem. The dimensions also I am giving. $20 mm above HP and $30 mm in front of the VP. And the second problem is $20 mm above HP and $35 mm in front of $35 mm behind the VP. So we'll draw the projections. So this dimension is 35 mm and here 25 mm. And coming to the third problem is here. So point C is 30 mm below HP and 40 mm behind the VP. I am already telling that the one of important note, above and below means we will draw the front view and behind and in front means we will draw the top views. So the point C is below HP and behind the VP. So below HP and behind the VP, the point C is in third quadrant and we will draw the projections. By taking the distance between the projectors is we can take 25 mm distance and we will draw the projection of point C. Point C is 30 mm below HP. Take 30 mm below the reference line and draw the front view. And behind 40 mm, we can take 40 mm behind and we will draw the top view of point C. So the top view of point C is small c and front view of point C is C dash. So after drawing the projections, we will give the dimensions also for the third problem. So you can take 10 mm distance from the projection line, from the projectors, and we will give the dimensions. So this dimension is, they are clearly giving that 30 mm below HP and 40 mm behind the VP. And coming to the fourth problem, point D is 30 mm below HP and 50 mm in front of the VP. Take 25 mm distance again, because they are giving the distance between the projectors 25, and draw the projection of point D. So D is below HP and in front of the VP, so the point D is in the fourth quadrant, below HP and 50 mm in front of the VP. So below HP means we will get the front view, in front means we will get the top view. So 30 mm below, both the views will get the below the reference line. 30 mm below, we will draw the front view, and 50 mm in front with extending that line 50 mm, and we will draw the projection of point D. So this distance, so here we will get point D dash, below means, so in front, so we will get the point D like that. So draw the projections. So here the object is in the fourth quadrant, so we will draw the projections like that. So after that we will give the dimension. So this dimension is 30 mm below HP and 50 mm in front of the VP. So we need not to draw the rough diagram, just you can follow the important note and we will draw the diagram, we will draw the projections. So I am already telling that above and below we will draw the projections, and below and in front and behind we will draw the projections of top view, and above and below means we will draw the projections of the front view. But we can identify whether the object is in which quadrant and we will draw the projections. Now we can take another 25 mm distance and draw the projection of point E. So take 25 mm distance and draw the projection of point E. Point E is in the HP. In the HP means on the reference line. And 40 mm behind the VP. So 40 mm behind means above the reference line. So you can take 40 mm above the reference line and draw the projection of point E. So in HP, on the reference line we will get one projection, and 40 mm behind. So behind means we will get the top view of point E. And the front view is we will obtain on the reference line here in this condition. And coming to the next problem, we will give the projection also, he will give the dimensions also. This dimension is 40 mm behind the VP. Now you can take another 25 mm and draw the projections of point, another point. So the point F. Point F is in the HP. In the HP means on the reference line. And 30 mm in front of the VP. 30 mm in front of the VP means below the reference line. Take 30 mm. Take 30 mm. And we will draw the projection. So here you will get one point and here you will get one point. In front means always we will draw the side view. We will draw the top view in front. So here you will get the point F front top view F. So here you will get F dash. And coming to the next problem, point G is in the VP and 50 mm below the HP. So take 25 mm distance and we will draw the another diagram. So point G is in the VP and 50 mm below the HP. Below, take 50 and draw the projection of point G. I am already telling that the below and above means we will draw the front view dimension, front view projection. So the point G of front view is we can representing with small letters with the dash, and on the reference line G is in the VP means on the reference line we will get the top view of point G. small g. And now draw the another problem. Take 25 mm distance. So point H is in the VP and 35 mm above HP. Take 35 mm above HP. Above means above the reference line we will get the front view. Front view of H is small h dash. On the reference line we will get the top view, small h. And similarly draw the last problem. Point I is on both HP and VP. So on both HP and VP means on the reference line we will get the both front view and top view. So take 25 mm distance on the reference line. We will draw the projection of point I. So front view of point I is I dash and top view of point I is I, small I. So draw the projections, so top view and front view on the reference line both. Now we will draw the projection, we will draw the dimension lines. Draw the dimensions of different points. So here I am drawing the dimensions. So F dimension 30 mm in front of the VP, G dimension 50 mm below the HP, and here 35 mm above the HP. So like that we will solve the problem. So for solving this problem, first of all I am taking a common reference line and draw the projections one by one. Common reference, the distance between the projector. So the distance between one projector to another projector I am taking 25 mm distance. So that value is also I am representing here. 25 mm distance I am taking, distance between the projectors. So by following a method, so we'll draw the if you follow the observation, if you follow the rough diagram, or if you follow the method, so like above HP and below HP we will draw the front views of points, and in front and behind we will draw the top views of that points, and we will construct the diagrams by observing whether the point is in first quadrant or second quadrant or third quadrant or fourth quadrant. We will construct in the projections like that. A point A is in the HP and 25 mm in front of the VP. Point B is also in the HP and behind the VP. They are not giving the behind dimension. The distance between their end projectors is 55 mm. Draw its projections when the line joining the top views makes an angle of 50 degrees with respect to the reference line. Also find the distance of the point B from the vertical plane. So sometimes they are giving the plan or elevation. Elevation means we can call it the front view or the side view, and plan means we will draw the top view. Top view makes an angle. Plan makes an angle means top view makes an angle. So first of all we will draw the reference line, and we will draw the projections directly. We will draw the reference line. By drawing the reference line, we will draw the projections one by one. First of all, point A projection we will draw. A is in the HP and 25 mm in front of the VP. In the HP means on the reference line, and take 25 mm in front means below the reference line you can take 25. Take 25 and draw the projection of point A. So in front means we will get the top view of point A, and on VP means on the HP means we will get the front view of point A dash and A. And now they are giving that the distance between their projectors is 55 mm. So you can take 55 mm distance from the projector, from this projector, and we will draw the projection of point B. Point B is also in the HP. Point B is in the HP, and behind the VP, but they are not giving the dimension. So I am drawing this dimension as a vertical line like that. But they are giving that when the line joining the top view makes an angle of 50 degrees with the reference line. So the reference line is look like an horizontal line here. So from the reference line, so top view is here point A. So from the point A, just we will draw a reference line, we will draw a horizontal line, and by making an angle of 50 degrees in this direction, by making an angle of 50 degrees, I will draw a line joining up to the projection of point B, up to here, projection of point B, we will draw a thick line. And this projection line, this line will intersect the projection of point B at point small b. So this is the projection of point B, top view, and here we will get the front view of point B dash. What they are asking in our problem, find the distance of the point from the VP. So from the VP means, so behind the VP, so this distance B dash to B distance we can measure by using your scale. So we will get 51 mm. I am getting 51 mm. So we can, this line is thick line here. So I am measuring this distance and I am getting this distance is, I am representing here. They are asking in our problem the distance, what is the distance between point B from the vertical plane. So how much we will get? 51 mm. So this distance, this is given in our problem 25 mm. What they are asking, so you can represent it in brackets. So B dash is 51 mm. So you can represent it like that. So you can draw the diagram like that. So after that we will give the dimensions which are giving in our problem. They are giving the dimension of point A and also they are giving the distance between the projectors also. So we will mention that dimensions also in our problem. So this projectors is 55 mm distance. So like that we will draw the projection in this method. And angle is also, you can represent it, this angle is 50 degrees. Point P is 30 mm above HP and 25 mm behind the VP, while another point Q is 20 mm above HP and 40 mm in front of the VP. If the distance between the projectors is 60 mm, draw the projections. So we will draw the projections one by one. So here the point P is 30 mm above HP. We will draw the projections by drawing the reference line. Draw the projections of point P initially. So 30 mm above HP. So take 30 mm above the reference line and draw the projection of point P. 25 mm behind. So above and behind means, so the object is in the second quadrant. So on the same projection line, take 25 and locate point P dash. So above we will get the P dash, small P dash, 30 mm above. So behind 25 mm, so we will get the top view of point P, small p. I am giving the dimensions also here. After that we will draw the projections of point Q by taking the distance between the projectors is 60 mm. So we can take 60 mm from this projector. We can take 60 mm distance and draw the projection of point Q. Point Q is 20 mm above HP and 40 mm in front of the VP. Above HP and in front of the VP. So the object is in the first quadrant. Draw the projection of point Q. 20 mm above. Take 20 mm above. and 40 mm in front means below the reference line take 40. So here you will get the Q dash and here you will get the Q. So point Q, front view is Q dash and point Q top view should be notating with small q. So the point notation should be represented like that. So after that they are giving that also mark the projections. What they are asking, also mark the projections of the line joining P and Q. They are asking that draw projection line joining their projection. That means we will joining the front views and also top views. I am drawing the, first of all I am joining the top view P comma Q. And also front view also you can joining P dash and Q dash join. So this is our problem which are giving in our problem. So after that, after drawing this one, we will draw the dimensions also. So this dimension is they are giving the 30 mm above and 25 mm behind. And also we will representing this dimension also. So this is 20 mm above HP and this is 40 mm in front of the VP. They are giving the distance between the projectors also. You can represent that dimension also in our problem. So this dimension is they are giving that 60 mm. So this is the solution of our problem. Point A is 25 mm above HP and 30 mm in front of the VP. Point B is 20 mm below the HP and 35 mm behind the VP. The end projectors are 50 mm apart. Find the lengths of elevation and plan of the line joining points A and B. Also measure its inclinations with respect to the reference line, XY line. So whatever the problem is giving in our problem, just we will draw the reference line and we will constructing here. They are asking that find the lengths of elevation and plan means find the lengths of front view and top view. And also they are asking that its inclinations and front view inclination and also top view inclination also you can measure in our problem. So first of all we will draw the reference line XY. So after drawing the reference line, so first to draw the projection of point A. Point A is 25 mm above HP. 25 mm above HP, you can take 25 mm and draw the projection of point A, and 30 mm in front means take 30 mm below the reference line and draw the projection of point A. So 20 mm. So here you will get the A dash because the point A is in the first quadrant. So here you will get point A, small a. And so distance between the projectors is they are giving that 50 mm. So take 50 mm distance and we will draw the projection of point B. Point B is 20 mm below HP and behind the VP 35 mm. Below HP and behind the VP we will get in the third quadrant. So in the third quadrant, so below HP is 20 mm. Take below 20 mm. And behind the VP 35 mm, that means take 35 mm above the reference line and we will draw the projection of point B. So in third quadrant above the reference line we will get the front view of top view of point B, and below the reference line we will get the front view of point B, B dash. What they are asking is here, find the lengths of elevation after line joining the points A and B. Thus that means we will joining front view and top views, joining A double dash and A dash and B dash. Similarly joining AB, because these are the top views. They are asking the length of front view and length of top view. Length of front view and also length of top view. And also they are asking the front view inclination and also top view inclination. So we'll find out. So first of all, I am finding the length of front view. So I am finding the length of front view is, we will get 68 mm is the length of the front view. That means they are asking that here A dash and B dash. A dash and B dash length is, we will get 68 mm. And also I am finding the length of the top view. Length of the top view is, we will get 82 mm. So AB is, we will get 82 mm. And also they are asking that inclinations with respect to plan and elevation. So this inclination and also this inclination we can find out. Directly just we will draw a horizontal line from point A. Similarly from point A dash also we will draw the horizontal line and we will draw the inclined line. So we will find out the inclination with respect to the reference line. I am finding the front view inclination. So the front view inclination is, we will get 42 degrees, and the top view inclination, is, we will get 54 degrees. 54 degrees, and the front view inclination is 42 degrees. So the inclination with respect to front view, so we can denote it with theta. So this one is, we can denote it with phi. So theta is, so we will get 42 degrees, and phi is, we will get 54 degrees. So we will represent it in a bracket like that. So they are asking these values in our problem. So you can represent it in a bracket, in a table. Okay. So this is our required diagram. After drawing this diagram, so we will draw the dimensions of this problem. We will give the dimensions. So they are giving that this dimension is 25 mm above and 30 mm in front of the VP. So this dimension is 35 mm behind the VP and 20 mm below the HP. So like that we can solve the problem. So this is about the problems based on projection of points. So whenever a point is giving that, we will draw the projections like that. So in projection of points, so we can identify the point is in which quadrant, and we will draw the projections of points.